Okay, welcome to another Orbiter 2010 video. Now, in the last part of this video, we set up a journey to go from Hal Base on Phobos over to Deimos, and I have a copy of Hal Base sitting on Deimos, so we have a target to aim for once we get there. Ran into a little bit of trouble in the last video getting IMFD set up. There's just an issue with where it doesn't work quite the way I'm used to when you're on a body that has a gravitational influence that's basically nothing, or it's very low. What ends up happening is that IMFD realizes that the body that you're orbiting, in this case Mars, has more of an influence than the body that you're actually on, which in that case was Phobos. But I've also ran into this when I'm around the moons of Saturn that are much larger. You know, they're big enough to have they're big enough to have a spherical shape like a regular moon. But Saturn is just so massive that it has more of a gravitational influence than the moon that you're on. Like when you're on Enceladus, for example, when you're on the ground, you have a gravitational influence of 0.10 according to Orbit MFD. So that means if you want to go from, say, Enceladus to Titan, as an example, you'll run into this kind of a problem as well. So we'll deal with that another day, but that's something I wanted to point out. I'll go ahead and switch camera views here. And if we take a look outside, we can see that we really haven't gone anywhere. We haven't gone anywhere since the last video because I hit pause right after. So let me go ahead and unpause. And there you can see us, drifting away from Phobos relatively quickly in the very cool Aero Freighter. So we're going to go ahead and warp time forward until we're more than halfway over to Deimos, and then we're going to see what we can do to correct some of this error in our PEA. When I did the transfer, when I left Phobos, I didn't get a PEA of 0, which is what I really want. It doesn't have to be exactly 0, and we don't want to aim for necessarily the middle of Deimos, but we want it to be, right around 0, and we're off by, we were off originally by over 300 kilometers. That may not sound like much, but you got to remember that these orbits are so close, that's actually a pretty good number. So let's go ahead and warp time forward, get a little bit farther out. You can see this is where we are if you look closely in IMFD, and you can see our PET, that's how long it's going to take us to get there, which is only 30,000 seconds. So we're dealing with a pretty small system here. We're going from one asteroid essentially to another one. So climbing out away from Mars. Go a little faster. Let's jump back inside to see exactly where we are. So we're already out to here, and we're going to there. So let's get a little bit farther away, get a little bit less gravity from Mars. I think what I'll do is I'll just use that spot right there, and for no other reason than it's just a nice line. So right about here, we'll come back to 1x, and we're only 10,000 seconds away from Deimos now. Let's go ahead and look outside, see if we can see where all this stuff's at. Okay, so there's Deimos in front of us, which we can't really see very well because it's so dark. All right, let's now first of all, rather than setting up a delta V maneuver, I just want to see what happens if I just sort of tap translation here. So a little bit of inward, it's helping, and I'd say it's definitely a little bit better than what I was getting when I was in closer to Mars. So coming out this far is helping a little bit. And let me just tap plane change just to see there if we're getting anything. That's actually helping quite a bit. So somehow we introduced some plane change, or we missed having plane change correction. A little bit more on the inward, a little bit more on the plane change. Things are starting to slow down now. So more inward. We'll just go back and forth. It looks like we'll be able to get our PEA all the way down to the surface with just a little bit of translation. That's always nice, you know, so you don't have to mess with setting up a delta V maneuver. A little bit of plane change and more inward. Of course, I say inward, but you'll note that I'm not pointing to prograde. So inward currently would be more like prograde because of the direction that I'm facing. I'll show you what I mean by that. If I actually go to prograde, I'm actually almost retrograde at the moment. So inward from this vantage point is it's actually more like outward. So I'm going to go ahead and get the mighty arrow freighter facing forward, and you'll note that when I do that, if I now press inward, it won't give me a benefit necessarily because we're now facing a different direction. Now let's see which ones make the biggest difference. So if I do maybe a little bit of forward, that's hurting. So let me actually go backwards, you know, retrograde. That's helping. And now let's see what inward and outward do. See now this one's actually hurting, so I want to go the other direction. I want to go. Actually, neither one of them are doing me any good at the moment. So it's just going to be retrograde at this point. Actually, plane change is the winner right now. Yeah, we got our PEA all the way down to yeah. Let's go with that. Again, we don't want to try to target the center of Deimos or anything, especially not when we're this close. Okay, let's bring up orbit MFD. It's reference Mars. Let's target Deimos, and I'm just doing this just so we have some information to look at there. But we don't really need it because we have all that over there. Okay, let's go ahead and warp time forward. Now we're only 9,000 seconds out. And in fact, what I may want to do now, go ahead and reference Deimos and put that on the HUD. Yeah, let's actually do that. Now if I go prograde to Deimos, I should be looking right at it. Although being as small as it is, we won't be able to see much yet. Let's go F9, and there's Deimos out there, and yeah, we can't even hardly see it. It's even still. Okay, it's warp time forward. Get down to maybe 1,000 seconds out, something like that. Warping time forward at 100. We can afford 1,000, but we want to be careful. Actually, let's get down to 3,000 seconds and then see what burn time calculator says our braking time is going to be. Okay, we'll go with that. Let's go turn forward and look at Deimos now. Now, if we really want to be super fuel efficient, we want to be retrograde to Deimos because we'll get more braking out of the full power of the main engines. But you can see Deimos out there. It's still very dark because the sun is on the other side, so we're not getting any reflection off the front. So it probably doesn't really show up in the video playback. Okay, our difference in velocity between ourself and Deimos is currently 327 meters a second. By the time we get there, it's supposed to be 331, or let's call it 332, our periapsis velocity. That's what this number over here means. So if I bring up burn time calculator and I put in that number, and we'll just round up to 332. So we'll say delta V 332. Now it's telling me that if I use the full power of the main engines, which I'm not going to, but if I did, that I would need to begin braking when I'm at least 5,220 meters out. And in my opinion, you want to brake more than that so that you're in position above Deimos and you have time to do any maneuvers. So I would probably start braking at 6,500 meters. That way I give myself at least a full kilometer above the surface of Deimos. But we're not going to use the full power of the main. We're going to use the retros So we're going to actually begin braking when we are 20 kilometers. Let's round that up to 21. And then I'm going to say I want another kilometer on top of that. So I'm going to say 22 kilometers is when I need to begin my braking. And one other thing we can do, let's set up VOR VTOL now so that we don't have to scramble to do that later. So bring up ComNav on this side, and we're going to bring up HAL base for Deimos. There, I got HAL base 1 and HAL base 2. Fortunately, the frequencies are the same for both of them, so it doesn't matter which one I pick. Although I probably should change the name of the one on Deimos to like HAL base D or something. And we're going to say 129. We don't even really need the long range, so we're not even going to do that. We're just going to go for landing pad 4. That's the one. So landing pad 1, 2, and 3, those are the small ones that are meant for the Delta Glider and XR2. But the landing pad 4 is it's 3 times the size of the other one, so we're going to go for that one. That's going to be 129.90. So let's get that set. 129.90. Got it. Now we can go ahead and close that out. I guess we could set up the long range. That way we know at least when we're within 500 kilometers of Deimos. Let's go. So yeah, let's go ahead and do that. So we'll go 129.50. And now we can close it out, and we'll bring that up over here. So we want 129.50. So when this comes online, we know we're actually within 500 kilometers of Deimos. Let's bring interplanetary MFD back up and warp time forward a little bit more. I don't know if it shows us what our current distance is or not. Well, we have it up here. We're still 800 kilometers out. So when this gets to 500, this should come online. It'll be roughly 500. It may not be exact, but so right about, let's see how exact it is. So there is 500 right now. And let's see when this comes on exactly. And there it is. So again, it won't be perfect because there is some kind of logic built into Orbiter to attempt to give you, range distance based on how does it figure it out. It's like the higher you are above, like when you're on Earth and you're sitting on the landing pad at Cape Canaveral, you'll notice that there's like a little green line around your Delta Glider. That's your radio range. But when you get up to a kilometer, you'll notice that little green circle expands way out. And when you're up to 10 kilometers, it's much larger and so on. All right, so again, we said we needed to brake when we were 22 kilometers out, so we can continue forward for now. Can watch our altitude here. And here comes Deimos now clearly in view. Now there's one thing to consider. That is, this distance might be to the center versus to the surface. Well, that's not what that distance is. But I know when you have attitude MFD, the altitude it gives you is to the center of the object. And you actually have to account for that by adding a couple of extra kilometers, or else you'll start braking too late. But we're not going to have that problem here. So let's go forward a little more. And we're not going to have any problem of actually hitting Deimos anyway, because you can see our velocity vectors above it and past it. But let's get rotated. Get ready to begin braking here in just a second. We're at 28 kilometers distance now. Okay, getting ready to engage the full power of the retro engines. So we'll go now, just to make sure we don't overshoot here. You can see the retro engine there, and on the other side. And you also note when we do this, the other side of our orbit, you know, it starts expanding, because what really ends up happening here is we do this braking burn. We're basically making our orbit match the orbit of Deimos. So in order for that to happen, the low side of our orbit, which was over here when we left Phobos, that side of our orbit has to extend all the way out to here, because it makes perfect sense. You know, if you think about it, since we're basically rendezvousing with the space station in a sense. In this case, the space station is just a big hunk of rock. So in order to rendezvous with this big hunk of rock, our orbit has to match the orbit of this big hunk of rock perfectly. So in order for that to happen, then our orbital line that you see here will be exactly the same as Deimos by the time our difference in velocity is 0. And our current difference in velocity is 100 meters a second. And we don't necessarily want to slow all the way down to 0, because we do still have to find you know, Hal base, which I can tell according to this instrument here is going to be off to our port side. So we probably will slow down more or less to 0, because it's not going to do us a whole lot of good to go forward. Although it's to the left and it's forward, so we don't want to slow down completely to 0. In fact, we'll go with that. So killing the engine. Now we're going to put in a bunch of translation, or well, a little bit of translation, in order to make sure that we are moving off to the left a bit, and then we'll rotate over that direction. But you can see if you look at interplanetary MFD, our orbit now is almost perfectly matched with Deimos, and it will be perfectly matched here when we're done adjusting all of our stuff, all of our velocities. So let's go ahead and rotate. Go ahead and rotate now. And I'm just looking at the VOR, VTOL. Make sure it thinks we are heads up. Make sure the HUD thinks that we're heads up.
Translation. Rotation.
Okay, we are straight. We're heading straight to the base now, and I can actually see it coming up over the horizon, though it probably doesn't show up too well in the video playback.
Rotation. Translation.
Everything translated properly. And yeah, we'll go ahead and get landed here. We're at about 20 minutes on this part of the video, but I don't think we'll have any problems getting down here. Now, I do want to watch my altitude.
Rotation. Translation.
I don't want to end up going through the mesh or anything. You can go through the mesh, but I don't want that to happen. It just looks bad. Okay, so now technically we're climbing a little bit, and we don't really want to climb, so let's go ahead and get rotated so that we are level according to Deimos, or more or less level. We don't need it to be perfect, because you can see as we go forward, as we're coming up over the sort of invisible sphere that is Deimos, we're naturally leveling out. So that means if I bring my position all the way to 0 now, then we're going to end up pointing up. In fact, I could even go farther down. Matter of fact, we can probably go ahead and come all the way down to about 30, because again, as we go forward, it's going to just naturally straighten itself out. You can see what I'm saying. The HUD, the numbers, they're coming down, because what's happening is we're coming up over the surface, and it's such a such a small body that we come up over that surface very quickly. If you look really close there, you'll see Hal base. I'm going to put in a little bit of down translation again, because I don't want to climb. A little bit of translation to the left because I can see according to the VOR VTOL that my flight path is a bit off, so I can correct that. A little bit more down translation. Again, wherever the velocity vector is pointed, that's where you're going. So let's make sure we're going in the right place. And a little bit of time warp.
1,000. 500. 400. 300.
Let's come out of time warp now. Let's fix things a little bit.
200.
Translation.
Translate a bit to the left. The other left. My right.
Rotation.
And we'll get rotated so that we're even
100.
or level. No need for that. It's just in the way at this point.
Gear down.
Put the gear down before I forget about it. And there will be a little bit of maneuvering once I get over top the base. Kind of looks, these types of bases like remind me of oil derricks out in the middle of the ocean, like a mining platform. Okay, let's slow down a little bit. How fast are we moving forward? Yeah, we're moving forward at 26, so let's slow down.
Translation. Rotation.
Let's get rotated to the
50. 40.
Translation.
rotated so that we're level, and
Rotation.
start rotating now. Because I've noticed one thing about this landing pad, because it's at an angle, and that was necessary, but because it's at an angle, you can't have your VOR VTL perfectly to one of these, I'm going to call them cardinal positions, but north, east, south, or west. If it's perfectly lined up, you won't be lined up on the pad. So we're going to go until this is off of the center just a little bit. Maybe right about there. What you would actually want to do is know what the heading is, and I don't know exactly what it is. I just know it's not perfectly. I just know it's not perfect on one of these positions.
Translation. Rotation.
30.
Translation.
Just making sure I'm not sinking, because I don't really want to sink quite yet. Distance from the center of the pad, or the distance from where I'm going, is 200 meters. You can see that counting down.
Rotation. Translation. Rotation.
What I'm doing is I'm kind of slipping sideways over to the pad. So if I take a look outside, you can see, actually I'm not quite slipping in the right direction. It's kind of what I have in mind, but I'm not, see, I'm still not angled quite right, but I can't tell, at least not without looking outside, but I'm trying to slide over this way so that I can have the landing platform in front of me.
Translation. Rotation.
But I'll have to rotate now.
Translation.
Feel like a captain of a cruise liner or something trying to come into dock.
Rotation.
Maybe if I line up with the tower from my vantage point. So, right about here.
Translation.
Still don't feel like I'm lined up. Okay, now we'll go forward. Can't really see anything from the virtual cockpit. Yeah, even if you tilt your camera, you really can't see where you're going, so you have to rely on the instrumentation for sure. Okay. Still don't feel like I'm rotated quite right.
Translation.
50.
Go forward a little faster. Actually, come to think of it, I don't know where, like the VOR, VTOL, I don't know where it thinks 0 is at, because clearly we're not ready to land. And it thinks that I'm past. You know what, that might be my fault though. When I set this up, when I set up the landing pad, or the landing, when I set this base up on Deimos, I may not have done the radio tower quite right. So, just have to eyeball it.
Rotation.
Make sure we're level.
Translation.
Translate a bit to the right.
20.
Rotation.
Just rotating a bit because I don't feel like I'm straight. Oops.
10.
Translation.
We're almost down, just a few more meters to go. I can tell I've got to go forward still by quite a bit.
10.
Rotation.
Still don't feel quite straight. Maybe now. I feel like all this needs to be beyond my viewpoint before I can settle down. If it's not, then I feel like I'm back too far.
Translation.
But yeah, according to this, we're 300 meters past the landing pad. You know what though? Did I ever switch? No, I never switched over, that's why. So yeah, that is an accurate number, okay.
Rotate translation.
Okay, let's bring our horizontal speed to 0. Go level. And ease her on down. Okay, let's make sure that we kill,
Rotation.
turn off the level.
Translation.
And we just need to settle down now. Okay, I think we're settled down. It's a little hard to know for sure when you're landed on these really small bodies because the gravity's so slight that you don't get like a very clear, you know, ka-chunk type of feeling like when you come down to Earth, you know, or even the moon. There's a very definite sense that you're down. But on these bodies, it's like, you know, you drop a paper clip and it takes 8 minutes to fall to the ground, so you don't really know for sure when you're down. But I feel like, yeah, we're completely settled now. And we're basically straight. You can see it's not perfect. One way you can tell is like if you look at your landing skids. This one over here is going to be the best example. You can see how that landing skids right on the line, and like this one is a bit off, but it's pretty close, and that's actually a good angle there too. You can still see we're off, and really I think I even want to be a little more forward than what I am. Maybe actually, well, in terms of pillar support, it's probably right where it needs to be. The big heavy end is right on that big fat pillar. So that's probably like right where we need to be, but just otherwise it kind of feels like I'm a bit off back here. Because like if the crew had to come out and do any maintenance on the engines or something, you know, they're hanging off the edge. Whereas this part can still go forward, you know, by several more meters without being in the way of the hangar. You know, I think I may have requested this platform a little bit on the small side. We might have wanted to make like one more square so that it's 4 long. I don't know. It's still really good. Okay, anyway, that is a transfer from Phobos to Deimos, and we're over 30 minutes on this part of the video, so I'm going to go ahead and end it here. And if you liked the video, go ahead and hit the thumbs up, and if you didn't like it, hit the thumbs down. More importantly, leave a comment. And if you have any thoughts on using IMFD, specifically IMFD, not so much TransX, but specifically IMFD, if you have any thoughts on using that to transfer from one small body to another, go ahead and leave those comments down below. And give this flight a shot yourself. I'll leave a link in the description down below where you can download the scenario that I used when I started. Now, it will require that you already have HALBase installed, so make sure you have that. But yeah, you can at least start over there on Phobos using the same scenario that I used and see what you can come up with in terms of you know, a better solution. And the scenario uses whatever today's date is, so don't worry about using the same date that I'm using, just whatever date you happen to be running the scenario on, and see what you can come up with. See if you can come up with something way better than the 785 that I initially came up with there in IMFD. And I will see you in the next video. Okay, welcome to another Orbiter 2010 video. Now, in the last part of this video, we set up a journey to go from HALBase on Phobos over to Deimos, and I have a copy of HALBase sitting on Deimos, so we have a target to aim for once we get there. Ran into a little bit of trouble in the last video getting IMFD set up. There's just an issue with where it doesn't work quite the way I'm used to when you're on a body that has a gravitational influence that's basically nothing, or it's very low. What ends up happening is that IMFD realizes that the body that you're orbiting, in this case Mars, has more of an influence than the body that you're actually on, which in that case was Phobos. But I've also ran into this when I'm around the moons of Saturn that are much larger. You know, they're big enough to have they're big enough to have a spherical shape like a regular moon. But Saturn is just so massive that it has more of a gravitational influence than the moon that you're on. Like when you're on Enceladus, for example, when you're on the ground, you have a gravitational influence of 0.10 according to Orbit MFD. So that means if you want to go from, say, Enceladus, 3,000 seconds. So we're dealing with you know, pretty small system here. We're going from one asteroid essentially to another one. So climbing out away from Mars. Go a little faster. Let's jump back inside to see exactly where we are. So we're already out to here, and we're going to there. So let's get a little bit farther away, get a little bit less gravity from Mars. I think what I'll do is I'll just use that spot right there, and for no other reason than it's just a nice line. So right about just a Titan, as an example, you'll run into this kind of a problem as well. So we'll deal with that another day, but that's something I wanted to point out. I'll go ahead and switch camera views here. And if we take a look outside, we can see that we really haven't gone anywhere. We haven't gone anywhere since the last video because I hit pause right after. So let me go ahead and unpause. And there you can see us, you know, drifting away from Phobos relatively quickly in the very cool Aero freighter. So we're going to go ahead and warp time forward until we're more than halfway over to Deimos, and then we're going to see what we can do to correct some of this error in our PEA. When I did the transfer, when I left Phobos, I didn't get a PEA of 0, which is what I really want. It doesn't have to be exactly 0, and we don't want to aim for necessarily the middle of Deimos, but we want it to be, right around 0, and we're off by, we were off originally by over 300 kilometers. That may not sound like much, but you got to remember that these orbits are so close, that's actually a pretty good number. So let's go ahead and warp time forward, get a little bit farther out. You can see this is where we are if you look closely in IMFD, and you can see our PET, that's how long it's going to take us to get there, which is only, 30